Hi guys, today we're going to take a look at page 11 at the bottom and page 12 of the Unit 10 classwork packet. Once again, that would be page 11 and 12 of the Unit 10 classwork packet, and we're going to specifically look at inscribed quadrilaterals and the property of their opposite angles, alright? Now, first, a little bit of vocabulary here. What do we mean by inscribed quadrilateral? Well, inscribed simply means that each one of the corners, each one of the vertices, is on the circle itself. Those of you guys who did constructions like the inscribed hexagon, inscribed triangle, inscribed square would have remembered this, right? Especially those of you guys who have advanced topics as well. Now, when we say inscribed, all right, what that's going to do, and I'm just making a kind of a rough sketch here, what that's going to do is it's going to do something interesting for the opposite angles. And before I tell you what the property is, I want you to think about why it works. Does everybody agree with me that this right here is an inscribed angle? As in, it has two endpoints that are on the circle itself, right? Now, this angle right here happens to open up to this big blue arc. Everybody see that? Okay. Now, by the same token, isn't this angle right here also an inscribed angle? And doesn't it also open up to a slightly different arc, which I'm just kind of like doing jagged blue right here? Now notice, between the solid blue and the jagged blue, we've made the entire circle, right? So the entire circle is 360 degrees, and these two angles together, because they're inscribed, they're going to have to be half of that 360. What's half of 360? 180. Now that's a whole lot of mumbo jumbo for saying if a quadrilateral is inscribed in a circle, then the opposite angles are, and the word you write down is, supplementary. Or if you prefer, you can say add up to 180. Now just to make sure, what do I mean by opposite? Opposite means across from each other, not next to, across. So let's take a look at a few examples. This is pretty easy, I think, of how this is going to work. Let's take a look at a basic example first. Page 11, number 1. Now, this one right here is pretty straightforward. Here's my center. There's a chord. There are a couple other chords. All right, not that it really matters too much for this. And here we go. So this right here is 92 degrees and this is 45. So the basic idea here is that the angles that are across from each other, or as we know them, opposite angles, right? They're going to be supplementary. So 45 and this angle add up to 180, so all I gotta do is subtract from 180 in order to be able to find it. Look how nice that is. And so I get that this angle up here, angle K, is 135. By the same token, over here, this is 92, and this one's across from it. So the ones across from each other are going to have to add up to 180. So all I got to do is 180 minus 92. All right, so I do 180 minus 92. Let's make sure we remember how to borrow. Yes, of course. Right, and I get, I believe it's 88. All right, so J was 88, and K was 135. Now, sometimes they're not going to make life so easy for you, right? What they're going to do instead is they're going to force you to use a little itty-bitty bit of, they're going to force you to use a little itty-bitty bit of logic, right? And when I say logic, I mean taking information from previous parts of this unit and incorporating it into this one. So let's take a look then at number 2. Once again, which number? Number 2, okay? So number 2 looks something like this. Here's a center, da-da-da-da-da. And again, if this diagram is not great, well, just deal with it, right? This is the best I can do on such short notice, so we will just have to hope and pray for the best. So that's 90, that's 126, this is 93, and that's all they give me. Okay, first things first. Right away, because I have one angle, I know what the opposite angle is going to be. If this is 93 and this is an opposite angle, that means that these are going to have to add up together to give me 180. So let's do a little tiny bit of math here. So this angle right here is going to be 87. So we have S is 87. So far, so good. Now, do you guys notice how this angle right here is an inscribed angle? Again, what's an inscribed angle? It's an angle where the vertex is on the circle and the two kind of like line segment pieces are chords, right? So in this case, this angle opens up to both, I'm going to highlight it here, the 90 and the 126. What do those make up together, huh? I think it's like 216. Let's take a moment, make sure I did my math right. Yeah, I think it's 216. So if that whole thing is 216, and this is half of that arc, what's half of 216? Then this angle is 108, okay? And if that angle is 108, what's the opposite angle? Well, it's got to be supplementary with it, and so it's going to be 72. I know that was a bit fast, but if you think about it, we are bringing together a couple big ideas here. Big idea number one, inscribed angles, right, are half the arc, or I could think of it as two inscribed angles make the arc the intercept. Big idea number two, because of properties of inscribed angles, when I have a quadrilateral, so four sides, inside a circle, right, that's what we mean by inscribed, the angles that are across from each other are going to be supplementary, which is a fancy way of saying they add up to 180. All right? Okay, now let's take a look at a few where maybe there's a little bit of algebra, shall we? So let's take a look at page 12 now. What page number? Page 12. All right. And let's see how we would approach these problems. All right. We're first going to take a look at one that's pretty straightforward, which is number 5. Number 5 just asks us to solve for x. All right. Here's an inscribed angle, and here are here are a couple of chords that they give us. All right. This is 9x minus 5. And this is 68 over here. Now notice, these two angles, right, are opposite angles, and thus, because it's an inscribed quadrilateral, what do they have to add up to? Oh my gosh, they have to add up to 180, because they're supplementary. So I'm going to say 68 plus 9x minus 5 equals 180. Let's do a little bit of combining like terms here. So 9x plus 63 equals 180. Okay, a little bit of inverse operations, so I think that gives me 117. I hope I did my subtraction correctly, but, you know, well, I guess you will find out. And then I divide both sides by 9. All right, and let's check the math here. It goes in once. Ah, look, it goes in evenly. How wonderful. I guess something finally went right. So x equals 13 for this one. Now, this was a pretty straightforward problem because they just gave you the inscribed angles, right? They gave you the angles that were across from each other, and all you had to do was add them up, set them equal to 180. Every so often, though, things are going to be a little bit, shall we say, meaner, and let's take a look at one of those examples together, okay? And then that example is going to be number 8. Once again, which one are we looking at? Number 8, okay? If you guys need a TikTok break, you can always pause me or put me on mute and just make a video or something and post it, go viral, whatever, okay? But for those of you guys who are actually watching to learn, let's continue. Okay, so what have we got here? Number 8 gives us an inscribed quadrilateral. They tell me that this right here is 50. This is 96. And this angle's 12x minus 25. Okay, now here's the thing, right? If I have an inscribed quadrilateral, I know the opposite angles are supplementary. So I know that this and this have to add up to 180. Uh-oh. But I gotta know this first, right? I actually have to know what that angle is. Notice that angle is inscribed. What does that inscribed angle open up to? Well, if you take a look, it actually opens up to both the 50 and the 96 put together. So how many degrees is that? 96 and 50. So it opens up to 146. So if this is 146, and it takes 2 of these to make 146, how many degrees? How many degrees will that actually be? What do you guys think? I wonder. So if you'd like, you can actually write an equation, or you can simply divide by 2. And what's half of 146? This is going to be 73. Once again, where the heck did I get 73 from? That was too fast. Oh my gosh, let me go back. 146 I got by simply adding the 50 and 96 because that's the whole arc right over here. In a previous lesson, we learned that it takes 2 inscribed angles to make the arc, right? So if it takes 2 of them, right, that means that I could say 2x equals 146, divide both sides by 2, and I get 73. Alternatively, the inscribed angle is 1/2 of the measure of the intercepted arc, and so half of 146 is 73. So now I got my 2 expressions here, and all I gotta do is add it together and set them equal to, oh my gosh, 180. Alright, so let's do a little math here. 75, that would be 50, so what, 48? 12x plus 48 equals 180. That means that 12x equals, I think it's 132. Oh my gosh, remember my times tables. I think x is 11. Okay? So guys, again, basic idea here is very simple. If I have a quadrilateral, so if I have a 4-sided figure, doesn't matter what type, and it's inscribed inside a circle, the angles across from each other are going to add up to 180 degrees.